In this video, we're going to go over Java's collection classes, which are comparable to the standard template library in C++. We're going to be giving you a bird's eye view of the collection classes, going over the main concepts. And you will need to go into the Java API docs and also into the Java tutorials in order to drill down, in order to complete the homework assignment, and also to perform what other tasks you want with the collection classes. The best place to go for information about the collection classes is in the Java tutorials. You'll see that there is a trail called collections, and it has a number of subsections to it. The ones that I find to be most useful are the ones on interfaces, implementation, and algorithms. If you go to interfaces, you will see that it gives the different interfaces that are supported by collections, such as set, list, map. We'll be going over this, plus how to order objects. If you go to implementations, you will see the different implementations for the different collections. For example, for a map, you get a hash map or a tree map. Finally, there are general algorithms that operate on collection objects, such as sorting, shuffling. We'll be going over them. But again, the interfaces, the the implementations and algorithms are the trails that you want to look at. Aggregate operations are something we may cover later in the semester when we get to functional programming, but it's not something you need to worry about at this point. So what kind of collections are offered by Java? And they fall into two categories: unordered collections and ordered collections called maps. And under collections, there are four types: sets, lists, queues, and dequeues for doubly ended queues. So sets have no duplicates. Lists, as you might imagine, just store a collection of objects. Queues are first in, first out. So that means you add at the end of the queue, remove from the beginning. And they can also support priority queues. Then dequeues are doubly ended queues. They can be inserted to and removed at either end, and they are or can be used to support either stacks or normal queues. And then different from collections, although related to them, are maps, and they support key value pairs. Okay, so these would be hash tables or tree maps, and you have sorted maps as a subcategory where the key value pairs are going to be in sorted order. And you have not encountered interfaces yet in Java, but the collections are actually abstract interfaces that are not classes, but are a special construct in Java called an interface. We'll get to them in more detail later in the course. For the time being, you just have to know that an interface is like an abstract data type. It supports an API. Okay, so supports an API. So for example, with collections, there is a collections super interface that, from which, as you see in the previous slide, set, list, queue, and dequeue all inherit from. And collections has an API which includes things like a size method that returns the number of items in the collection, an isEmpty method that tells us whether or not the collection is empty, a Boolean contains, which takes an object and returns true false as to whether that object is in the collection, a Boolean add, which will allow us to add an object to our collection, and a Boolean remove, which will allow us to remove. And both for add and remove, the Boolean tells us whether the operation was successful or not. And finally, we'll get to in a moment, there's an away to also convert a collection to an array so that we can use it with certain older legacy code that requires arrays of objects. So this is called an API for Application Programmer Interface. And is a set of abstract operations that are supported by any collection. Then there are specific implementations of a collection, such as for a list, there's both a pointer-oriented linked list and there's an array list, which is an array. So, important thing is that our collections are interfaces and we'll instantiate them with specific classes such as a linked list or an array list. So the way that you declare a collection is just like you would with a template in C++. You use the brackets to indicate the type. So if I want a list that stores string, I would declare it this way. And remember, everything's allocated off the heap, so to actually get one, I'm going to have to create a list. And now I'd be ready to add things to the list. So for example, I could say mylist.add, say Brad. And that would add Brad to the end of the list. And there's ways to insert into the middle of lists and the like. You'll have to go into the actual documentation to do it. Again, this is just an overview lecture. So once you have your collection object, there are methods like add or remove to add and remove objects from our collection. Another thing that's going to be important to us is traversal of our collections. And there's basically two techniques for doing it. First of all, you can use the for each loop iterator to go through elements. So for our previous list, we could say something like for string s in my list. And now that's going to return, I could just say system.out.println s, and that's going to print each string in my list. So that's the easy way to iterate through a collection. Now maps are not collections, and so it's a little more complicated. With a map, as you will see, you're going to have to get a collection from it. So for example, if I had, let's say, a tree that was storing employees as values, I could say myTree.values, and values is going to return a collection of values from my tree that I can now use for my iterator. And if I want to just iterate through the keys, I could say key set, that would return keys, and if I wanted to get both keys and my values, I'd have to say entry set, and then here I would no longer be able to say employee. You'd have to use an entry object, which you can find out more about by going into the documentation for maps. So this was iteration technique 1, to use for each. It's the preferred one, but a second way to do traversal is to use iterators. And there's two reasons why you might use iterators. First, you must use them to remove objects from the middle of lists. So if you want to remove objects from middle of a collection, you would use an iterator. And then sometimes you have multiple parallel traversals, say of two lists. So you might be traversing multiple collections in parallel. And the way that an iterator works is it essentially has three methods that you care about. It has a Boolean method called hasNext, which tells you whether there's another element in the collection. There is a next method that returns the next element. E would be whatever type the collection stores. So with our list, E would be a string. And then an optional third method is remove, not supported by all implementations, but if it's there, it removes the current item from the list. And if remove does not exist, you get an exception thrown. So here's an example that uses an iterator. So you declare it as iterator. In this case, we're going to be iterating through strings, so it's a string iterator. It equals mylist, and every collection object has an iterator method that will return an iterator object that will allow you to iterate through its collection. And then I say it.hasNext. You'll notice I have to put a semicolon there. And now I could just say, for example, system.out.println it.next, and that would output the next element in the list. So again, two ways to iterate. One, you can iterate over lists using the for each construct. The other way is using iterators. The final thing that we typically want to do with collections is object ordering. Okay, and we may want to do that either explicitly using something like a tree map, or we might want to go and sort a list. So in fact, the collections, there is a collections class, and it provides a method called sort, which operates on a list collection. And it will sort the elements on a list into ascending order based on a comparison of the elements. And you may remember that strings, when you want to compare them, they have a compare_to method that returns an integer. And it turns out that if you want to be able to sort objects, they have to implement an interface called comparable. So there is a interface called comparable, and you specify the type that it will be comparing. It has a single method in its API, and it is the compare_to method, which takes an object of type T, and you would compare yourself against it, and you would return a number less than 0 if you're less than object. You would return a number equal to 0 if you're equal to the object, and you would return a positive number if you're greater than the object. And the way that you actually indicate that your class implements a comparator is when you declare the class. Let's say we had a class employee. You would say implements comparator, or comparable rather. I'm sorry, it should be comparable. And you would now, when you actually wrote employee, you would have to include in it a method, public int compare_to, and it would take an employee. And let's say we're going to do the comparison on, say, salary, which I know, let's say that we had a variable called salary. So one easy thing that you could do in this case is simply return your salary minus e.salary. Okay, and notice that what this does, let's say my salary is $20,000, and let's say that the salary we're being compared to is $10,000. Well, you can see that since we're greater than it, we're returning a positive number, which is $10,000, so that works. Let's say instead that the salary was greater than us. It was $50,000. Well, that works because now we're returning minus $30,000. Finally, if it's equal to us, then our expression is returning 0. So this is a perfectly fine way to implement our compare to. So any object that we want to be able to sort or compare has to implement this comparable interface and needs to have the compare to method. And one thing that I should have put at the top here is that when I say comparable, I actually need it to specify the type. So I actually had to say here comparable, and I'm going to have to write it very small. You get the picture. So I'd have to fill in comparable and then in braces say employed in order to do that interface. Now, there are times when I want to be able to sort an object, but I may not want to sort it in its natural order. So I was sorting their employees based on their salary, but let's say I wanted to do a separate sort of employees by name. Well, I can't write two compare to functions, but what the sort function will allow me to do, so I could say collections.sort, and let's say it was employee list. I'm allowed to give the sort method a second argument, which is something called a comparator. So there is another interface called comparator. And again, a single method, but instead of being called compare to, it's compare, and the reason is because it actually takes two arguments and you compare the two objects, and again it returns a negative number if object 1 is less than object 2, a 0 if object 1 is equal to object 2, and a number greater than 0 if object 1 is greater than object 2. So you can create a comparator in order to compare to two objects not according to their natural order. And we're going to show you that normally when you create a comparator, you create what's called an anonymous class. So we'll have sort employee list, and then you normally create an inline anonymous class. So here we'll call it new comparator, and it is of type employee. And the compare method, we're comparing based on strings. So our two parameters are E1 and E2. And if you remember how we compare strings, we can say E1.compare2. Sorry, E1, we're going to have to use E1 dot, we're going to have to get the string out of it. So we're going to have to say E1 dot name dot compare to, and it's going to be compared to E2 dot name. So that would be the way we would sort this list according to name rather than according to salary. And this is called an anonymous class because you can see there's no name for it. In fact, we are extending here an interface and creating a concrete implementation of it by providing an implementation of the compare method. This would create a dot class, which you would see as part of whichever class this code was embedded in. And it creates a single instance of this class which runs at this point in the code, or in this case is passed to the sort method. So that takes care of a brief description of object ordering. And one thing that you're going to have to be concerned about when you actually go to use collection classes is you'll want an implementation. So far we've been talking about interfaces. There are different implementations. So for example, with a map, you can see you can get a hash table, which is called a hash map. You can get a tree map, or you could get a linked hash map. For a DQ, you could get an array DQ or a linked list. For a list, you could get an array list or a linked list, so on and so forth. So you need to look up the different things. You can see here for queues, there is a linked list implementation, and there is also a priority queue implementation, which they emitted from the table. Finally, there is a set of generic algorithms that primarily work on lists. You'll see here that only the finding extreme values works on a generic collection. So the rest of these sorting, sort a list, shuffle the elements of a list randomly, like if you had a bunch of cards that would shuffle them, some routine data manipulation, which we'll show you in a moment, binary search on a sorted list, which presumably would be an array list. We're not, we'll show you composition, and then extreme values finds minimum and maximum. So the sorting, as you can see, is, well, let's actually go to the notebook. So sorting, what they're looking for, they do not use quicksort. The reason they do not use quicksort is because it's not a stable sort. So they want one that's fast. They want one that's order n log n. And they want something that's stable. And by stable, we mean that if two values, if we have two values and that are equal, if two values are equal, we'll call them A, B. Two values are equal, and A appears before B in the original collection. We'll say in the unsorted collection. Then it's going to appear before B as well in the sorted collection. Okay, so that's what we mean by stable. It preserves the order of elements. Quicksort does not obey the stable one. It may interchange things. So in fact, Java uses a merge sort algorithm for doing sorting. And remember, this just works on a list. And you can convert a map to a list using key set values or entry set, depending on which set of elements you're looking for. Okay. So going back then, just to do a quick look, we already said we can do a shuffle. With data manipulation, you can see we can reverse a list. We can fill a list with a specified value, basically to reinitialize it. We can swap two elements in a list. For example, if we're doing selection sort or some other kind of sorting. If we want to copy one list to another list, we can do that. Finally, if we want to do binary search on a sorted list, we can do that too. It would be best if it's an array list. It's not going to work so well with a linked list. And then on any collection, you can find either the min or max by using the min or max algorithms. And again, you'd need to look these up in the Java API, and you need to make sure that your objects implement the comparable interface in order to take care of that. Or you could drop in a second comparator if you want it to have a different order other than the natural order. So we're going to finish this up with just an example which may help you also with the homework assignment. And it shows you a tree map, and the first thing you should see is that the items in the collections all come from java.util. So here what I'm doing is I'm going to create a tree map with a set of employees. So down here you can see my employees are things like Brad and the salary that each of us earns. So Brad makes $25,000, Nancy makes $10,000, and so on. And we want to sort our tree map, in this case by name. So the first thing we're going to do is print things out by alphabetical order. Then we're going to convert it to a list and print it out by salary. And you'll see here what the output should look like. First, it comes out in sorted order by, actually up here. First, it comes in sorted order by name, Brad, Joe, Michelle, Nancy. Then it was sorted by salary, Nancy, Brad, Nels, Smiley, Joe, Michelle. And you can ignore the from iterator for a moment because that code is not in there right now. Okay, so you can see that we defined a class called employee. It's a nested class, basically has a salary and a name. Then we created a tree map, and it has a string and an employee. So string is the key, employee is the value. And now we use put method to insert 6 records into the map. And then you can see that we use the for each method to iterate through it, and we had to use the values method to actually get a collection that we could iterate through. And we simply print each of them out, and the iterator is going through them in sorted order. Now in your homework assignment, you're told that after you're given some handicaps, and you first compute the handicaps. So you have to create a tree that is ordered by name so that you can insert scores by name. But later you need to compute the handicaps, and you need to actually output handicaps. Well, if you want, you're free to create a second tree map, and you can simply insert the computed handicaps into the tree map. But you could also just create a list and add elements to the list and then sort the list. And so here I wanted to show an alternative way of doing things, which is that I have created a list object, and the way I do that is I create an array list, and you'll see that I simply drop in the values from the employee map, and the values are the employees. And then I'm sorting it by salary. You can see that I'm creating a new comparator object and doing a comparison based on the two employees' salaries. And so that sorts them now into order by salary, and finally I print them out as a list. Or I'm sorry, I iterate through the list and print out the values. So that concludes this video on the collections class. As I said earlier, you will need to dig deeper into the different APIs in order to complete the homework assignment and to use collections in the future.